Hey everybody, it's Mr. Carr again. Today we're going to be looking at 3.1, similar figures. So this entire unit is going to be talking about things that are similar, okay? Might think those are the same, but they're not quite, okay? So similar polygons. In similar polygons, corresponding angles are, are congruent, and corresponding sides are proportional, okay? So what does that mean when we talk about something being proportional? It means that is like we did in our algebra review lesson. If I have something that's 2/3 and this other shape is like, so if I say it's like a ratio of 2 to 3, everything is 2 to 3, okay? You'll see what that means when we get to some of these other ones. All right, so linear scale factor, that is the ratio of the lengths of corresponding sides. Okay, so we're going to look at this example here and talk about what that means. Let me use this example over here first, actually, now I think about it. So find the scale factor of the following, another typo there, not triangles. These are quadrilaterals. So this is just one of our polygons. And so this is what we mean by having a linear scale factor. We want to compare like these corresponding sides. Now, how do I identify what's corresponding? I look at where are they at in location to each other. So I like to highlight the fact that this angle is congruent to that angle is congruent to that angle, that one to that one, and then that one to that one. So those are all the corresponding angles. The sides are going to follow the same pattern. So this side is in between the angles 1 and 4. This is 1 and 4. This is 1 and 2, 1 and 2. So that's how I can identify my corresponding sides. Are they in the same location in comparison to each other? So I look at 5 over 10. Okay, if I look at 2 and 4, if I look at, let's put a box around those, 3 and 6, and I'll do triangle, 1 and 2. Okay, these all are the same ratios. Every single one of these reduces to the same thing, 1 over 2. Okay, so that's one thing I can use. I can use this k here is 1/2. Okay, or it depends on how I'm describing it. I could also say that k is 2 over 1 if I were to go the other direction. We'll talk more about how we want to define that k. But for now, just recognize that's what makes these polygons similar. They're not the same exact size. Okay, this one is a bigger one, but it's all proportional. Every side is 2 times the other one, or 1/2 like if I look at the other way. All right, so here's what we're gonna do. We're gonna determine if triangles are similar by kind of doing that right there. I'm gonna test them out. Okay, so I need to test 3 ratios. When I look at these here, I've got, again, I'm gonna highlight let's use a highlighter. Okay, I wanna highlight what is similar to what. Okay, what is corresponding, I should say. So one thing I'm gonna highlight quickly is 8.2 is in between angles 1 and 2, just like 6.15. Okay, from there, the other things I want to look at is what's shorter, what's longer. So for example, my longest side here is 12. In triangle B, the longest side is 9. Okay, so if I have no angle information, I can at least do that. I can compare long to long, medium to medium, short to short. Okay, so last thing here is 6 is the smallest side, just like 4.5. So that's what I'm going to compare. So my first case is, let's go with the shortest ones. I'm going to go 6 over 4.5. The medium is 6.15 over 8.2. Nope, I had that flipped. Should be, I went A to B. So that's one thing to be careful of too. Be consistent. So I'm going to do these all as A over B. So I'm going to go, where was I? 8.2 over 6.15. Okay, and the last ratio is 12 and 9. So we want to check, are these all equivalent ratios? So one thing you can do is kind of like what I did over here. Can they reduce to the same fraction? I can do that here. It's a little bit messy. Okay, so one thing I can do instead is I'm going to test this out by just doing cross multiplication. Okay, and all I need to do is test 2 of them. like for example, if I test this, if I do 6 times 6.15, does that equal to 4.5 times 8.2? Okay, so I got 6 times 6.15 is 36.9. And then 4.5 times 8.2 is also 36.9. Okay, so I know that 1 and 2, those two ratios are equivalent. So the next thing I'm going to check is 2 and 3. So I'm going to do 9 times 8.2 and 12 times 6.5. So does 9 times 8.2 equal 12 times 6.15? All right, so 9 times 8.2 gives me 73.8. And then 12 times 6.15 also gives me 73.8. Okay, so here's the thing. I know that 1 and 2 are equivalent, 2 and 3 are equivalent. I could test 1 and 3 if I wanted to. I'm going to trust that it's okay though. Okay, so yes, these are similar. Since I've shown that the first two are the same ratio, the second two are the same ratio, I'm going to jump to the conclusion that 1 and 3 are the same ratio. Okay, if you really want to test it, you can do 6 times 9, that's 54. And then 12 times 4.5, which is also 54. All right, now as for the similarity statement, we are going to do this kind of like our congruence statements from last unit. I want things to line up. And so what I mean by that is this. Let's just do different colors in here. I've got angle L has the 2 arcs, just like angle, I think it's supposed to be T. And then I've got angle M and P line up. And then that leaves me angle N and O. So when I make my congruency or my similarity statements, then I'm going to start with triangle. Doesn't matter where I start, but I'll go with LMN. Okay, so I went L to M to N. Red, orange, purple, magenta. I don't know. Neon. Not a art person. I'm a math teacher. So, okay. So that means then that's going to be similar. That's what this symbol means. Is similar to. Okay. Looks kind of like congruency, but without the equal sign. So we're going to say is similar to triangle. I went red, orange, purple. So it's going to be TPO. Okay. It has to be lined up like our corresponding. So from my similarity statement, L and T are match up, M and P, N and O. All right. Okay, which of the following triangle measurements represent a similar triangle to 6, 8, 10? So again, when I look at these, I don't have any angle measures, but I can do kind of like a short, medium, long. So that's what I'm going to test. If I look at what's the ratios of short, medium, and long. Okay, so in case A, my short side is 6, my short side in A is 18. Okay, so this was case A right here. I'm going to do B, I'm going to do C. The medium is 8. The medium here is 24. Okay, and then the long side is 10. The medium is 30. So I reduce all those. 1/3, 1/3, 1/3. A is similar, that works. Okay, section B here. I'm going to do the same thing. I'm going to do 6 over 1.5. And then I'm going to do 8 over 2. And then I'm going to do 10 over 2.5. Okay, so 10 over 2.5, that is 4. 8 is divided by 2 is 4. I'm going to double check 6, but I believe that is also 4. Yep. So these all reduce to 4, so that means that B is good. And again, I'm comparing short to short, medium to medium, long to long. Okay, so for case C, short is 6, short is 12, 8's a medium, 16's medium, and then 10 to 18. So 6 over 12 is 1 over 2, 8 over 16, 1 over 2, 10 over 18, 1 over 2. That is 5 over 9. So that means C is not similar. All it takes is one pair to not match up. Doesn't matter if I have 2 pairs match up like this. One pair messes it all up, so it's no good. All right, so let's talk about this. In the diagram, ABC is similar, remember they're similar, to triangle DEF. List all pairs of corresponding sides. All right, so all pairs of corresponding sides. If I look at that, again, I'm going to go short to short. So 8, or sorry, I'm looking at some, I got ahead of myself. All pairs of corresponding sides. So I'm going to, well, yeah, I'm still going to do that same thing of short to short. That's BC and EF. So BC to EF. Those are corresponding. Okay, then I'm going to look at medium to medium. So that is going to be AB to DE. And my last one is long to long. Okay, and that's going to be AC to DF. Now, I also could have gotten this just from the statement. AB is the first two, just like DE, AB and DE. BC are the second two, just like EF. And then A and C are first and third, DF is the first and third. I don't know why it says 4 ratios, but we can look at 3 ratios here. Okay. The 3 ratios we're going to look at is we got 8.8 over 13.2. Is that equal to 9.6 over 14.4? And is that equal to 12.8 over 19.2? And again, because these are decimal numbers, I think it'd be easier to do my cross multiplication like that. So I got 14.4 times 8.8, 13.2 times 9.6. So we have 14.4 times 8.8 is 126.72. 13.2 times 9.6, same thing, 126.72. The other one I'm going to test is this one. Okay, you didn't quite see that. I'm going to test, whoops, wanted that. I'm going to test this right there. Okay, so 9.6 times 19.2, does that equal to 14.4 times 12.8? So 9.6 times 19.2 gives me 184.32. And then 14.4 times 12.8 is same thing, 184.32. All right, so now as for the scale factor, that's where things get a little bit tricky. The scale factor is that I would compare something like this. I would want to simplify one of my things here. Okay, so I'm going to pick the small one. I'm going to go with this one. One thing I can do is decimals. I can move the decimal place over both cases there. So I can rewrite that as 88 over 132. Because now, when I take that and I reduce it, I get 2/3. There's my K value, 2/3. If I look the other way, that would be 3/2. Okay, so this is the ratio of smaller to larger triangle. This is larger to smaller triangle. So that's what we're looking at K. So again, it just depends on how I ask you. If I say from small to large, do it as the 2/3 like that. If I say from large to small, it'd be the 3/2. Okay, so example 3, find linear scale factors on unknown sidelines. Remember, proportion is a comparison of equal ratios. So in this scenario, triangle ABC is similar to triangle DEF. What is the scale factor of triangle ABC to DEF? Well, I just need to compare 2 corresponding sides for the scale factor. When I do that, I'm going to look at 7 and 3. And the reason why? Because if I look at B and C is the second 2, EF, second 2. That's how I know they're corresponding. So if I look at from larger to smaller, I'm just going to say K is equal to 7/3. What is the length of ED? So ED is this one right here. Call it X. So that lines up with the 21 is corresponding. Well, here's the thing we have to do. When we want to solve this, I'm going to set up a proportion. That's the comparison of equal ratios. Since my linear scale factor is 7/3, that means every single side length is also in that same ratio of 7/3. So that's why I can do this. If I do large over small, I'm going to do 21 over X. Okay, that's how I set up those ratios. So I've got large triangle over the smaller triangle. If I flipped it, it's not a big deal. it would be small over large would be 3 over 7, but then that would be x over 21. So that gets flipped as well. Either way works. Bottom line is I am going to cross multiply. I'm just going to write over here 7x is equal to 3 times 21. So 7x is equal to 63. Divide by 7, and x equals 9. All right. There's my length of ED is 9. Okay, in the diagram, what is the scale factor of LMNP to FGGHJ? Again, scale factor, just compare two corresponding sides. Doesn't matter. As long as they're similar, which I'm saying right here, then it does not matter what I pick. So I'm going to pick 15 and 12. Okay, so I'm going to do it as, I'll do it large over small. Okay, so that's going to be 15 over 12. Divide everything by 3, I get 5 and 4. So that's my k, 5 over 4. Find the value of x, that corresponds with a 40. I'm still going to set that up as 5 over 4, large over small, 40 over x plus 12. Okay, and now it's just a matter of cross multiplying. So I've got 5 times x plus 12, 4 times 40. Distribute that, I got 5x plus 60 is equal to 160. Subtract that over, and I'm going to get 5x is equal to 100. Divide by 5, and I get x equals 20. There's my answer. Okay, and again, recap of this. If I have two similar figures, step 1, identify the scale factor. Take a pair of corresponding sides, reduce that fraction. Step 2, if you need to find a missing side length, set up that linear scale factor, set it equal to the corresponding ratio you're looking for. All right, last example with our ratios. The lengths of the sides of the triangle have a ratio of 1, 2, 3. The perimeter of the triangle is 60 yards. What is the length of the smallest side? So it's kind of like I did before in some other ratio stuff. Okay, but I'm going to add another row. So if I look at this, my ratio is 1, 2, 3. So it's kind of like side 1, side 2, side 3. I'm curious about the perimeter. So just like I did before, if I did like segments, I mean, I did segment ratio, I did part plus part equals whole. I'm going to do the same thing here. I'm going to take side 1 plus side 2 plus side 3. If I add those sides together, I get to the perimeter. So that's what we're looking at. 1 plus 2 plus 3 is going to give me 6. Okay, the perimeter is 60. Find the length of the smallest side. So that's what I can set up. I kind of just did the same box here, but I just don't care about these two pieces of information. That's how I can set this up on here. So I'm going to look at 1 over 6. So let me highlight it with the here. 1 and 6 is going to be equal to x and 60. These are all proportional. So small side to the perimeter is equal to small side to the perimeter. All right, so now cross multiply. And I get 10 as my answer. Okay, and so this was in yards, so the smallest side is 10 yards. Okay, you try now, we'll save that for tomorrow. But, excuse me, biggest thing about example 4 here, this wasn't the only way to set this up. So try it out. If you find other ways that make sense to you, use that. Okay, otherwise, trust this one. So I set them up as part plus part plus part equals perimeter. Side plus side plus side equals perimeter. Then I set up over here, these are the actual lengths. The only thing I know is perimeter. So that's why I was able to put that in there. I'm looking for the smallest side. If I said find the largest side, I would fill in that blank. If I want the medium side, I fill in that blank. It just depends on what the problem's asked for. Okay, all right. That's it for 3.1. I will talk to you later.